Good morning, everyone. You hear me okay? All right, happy Friday. Start with that. It's a Friday, so I'm pretty religious about my weekend. This is a bit of a dreamy session, so I will start with an apology, partly because I'm Canadian and we like to apologize a lot. This is a dreamy session. I'm not here suggesting any real concrete solutions, more like throwing ideas out there. So 2 things I would appreciate from you. If you have any questions at any time, please stop me, ask me. If you have any ideas, raise your hand. I'd love to hear your ideas. Again, the whole idea here is to start a bit of a thought process and see if, we have people who are also aligned in this kind of thinking and mentality. So let me know. The other thing I'll also mention is I'm from an imaging background. DICOM is my bread and butter. Work a little bit with FHIR, but this talk will be focused on imaging because this is the area I know relatively well. But hopefully whatever I'm pitching today is something you could take and apply to other parts of the clinical workflow. So towards the end of my talk, I'm actually going to start dissecting some of the FHIR resources and kind of looking for ideas for improvement in analytics. But again, these are the FHIR resources I know relatively well. A lot of you probably know the others a lot better than I do, so something to think about in the future. The title of the talk is a little bit unfortunate because I couldn't really come up with a better term. I called it operational analytics. But the general theme here is operational efficiency, ways to improve efficiency. Analytics is the easiest term that you could throw on it that people understand. But then analytics kind of puts you in that little corner box of thinking about graphs and dashboards and whatnot. But here I'm going to be talking about a lot more than just that. Are we clear? Good start. I hope everybody had enough coffee. Quick introduction myself. So I'm a software engineer by training. I work at Philips as Advanced Development Director. So basically my work is to prototype things. It's nice to be able to write code and not have to worry about maintaining it. I'll just say that. Throw it over the fence and be like, somebody else owns this now. I'm also involved with the SIM organization, so that's the Society of Imaging Informatics in Medicine. It's a North American-focused organization for imaging informatics education and advancement. The slides are Philips branded because I stole them from somebody else and added my own content. That's why they're not FHIR DevDays. Sorry, Irene, I see you there in the back. So next time I'll do a better job at using the template. All right. Quick look at healthcare today. Definitely have some challenges. If we start all the way on the left side, we have constant growth, right? Healthcare nowadays is bigger than ever, and it's only getting bigger than ever for multiple reasons. If you look at something like baby boomers, the population is always growing, so there's more healthcare volume being requested. Nowadays, you also have more clinical data per decision. So for example, when you do have a problem, you go to the doctor, you're more likely to get a lot more tests and imaging done than what you did 10, 15 years ago, because that's just the norm, right? And then the more data per clinical decision also speaks to the fact that now we have a lot more systems in healthcare that are also generating data. Back in the day, you may have gotten an X-ray, which wasn't even digital at the time. You guys remember the days when you got your film and you actually took it home with you, and like if you had to go see another doctor, you'd have to take that film with you everywhere. So not only are we digitizing things, but now for the more complex exams like a CT scan, they may be generating 3D reconstruction, they may be generating annotated data, they may be generating a whole bunch of things. So we're storing a lot more data that has to be processed, looked at, maintained, stored, privacy concerns, security concerns, etc. And then when you look at the actual money in healthcare, well, 80% is going to operational expenses. So just spending on your day-to-day stuff, and you're only left with about 12% available for you to spend on expanding your capital, so like buy new equipment, buy new software, that kind of thing. This is so far not painting a really good picture. I hope you can see this pretty clearly. And of course, we have shortages, because not only do we have growth on this side, but then we have less and less sort of radiologists and technologists graduating from schools to meet demand. And then, people are having like burnouts and they, disappear and that kind of stuff. So that just makes it harder, like scheduling shifts. The people I know at hospitals who schedule shifts, they grow gray hair very, very fast. Let's just say that. And then last but not least, we have reimbursement changes. in the US, I'm sure everybody is hearing about the new value proposition. Sorry, I forget what the actual legislation was called. I'm based out of Canada. But the general theme is true everywhere. The days are gone when your doctor could pretty much willy-nilly order medication or tests or imaging exams. Everything now needs to be justified, clinical decision systems, and there are more restrictions on what needs to be done if they want to get the money, and obviously everybody at the end of the day would like to get paid for their work. So all of this presents a major challenge for the healthcare environment, and specifically in this case, imaging. What do we do? Let's take a step back outside of healthcare and just compare about the rest of the world. What does the rest of the world do, and what can we be inspired from? So I'm actually going to start on the right here. Let's take a few examples. So one of them is package delivery. I'm not sure what examples you have here in Europe. I don't live here, but in North America, it's very common. If you go and order something on Amazon, you'll get an email the morning of your delivery to say, hey, your delivery is going to be out today. Here's a link where you could track your driver. And in the link, it'll tell you something like, okay, you're number 10 out of 15 deliveries I have to do. You've got like a 1 hour, half-hour window to expect them there. And when they're actually on your delivery, you can pretty much see them in real time coming over to your house. So that helps you plan your day. Like if you actually need to be home for that delivery, instead of stepping out for an appointment, you can actually stay home. But if you think about behind the scenes, the number of APIs and data sources that are actually being tapped here for you is astonishing, right? Because Amazon is talking to the delivery company. The delivery company is probably talking to a bunch of sources, including like the driver's smartphone and the GPS sensor, and all that data is basically being processed to give you something very concise. Here's a map, here's the guy, here's a time. Like so much data being distilled into basically like 3 or 4 points. So that's one example. Anybody who flies these days have probably been through this now too. There's a flight delay, you're going to miss your connection or a cancellation. Usually in the same message you get from the airline saying cancellation or delay, you'll also say you've been rerouted, here is your new flight. And again, think about all the cool APIs that are happening behind the scenes, like the airline is talking to the airport APIs and booking APIs, managing all that stuff for you, and again, distilling the information to you, here's your new flight time, your connection is missed, here's your new flight. Done. You don't have to worry about rebooking, you don't have to worry about thinking about any of that stuff. And the same example applies for telling you where your baggage is. Because if you think about sort of the stops here, right, like the airport determines this, airline has got to find out about it, and then the airline's got to be able to push notifications to the individual passengers. All of that stuff is being handled for you behind the scenes. And then last but not least, now you've got the new sort of next generation weather apps that not only predict the weather, but can link it to your real life patterns. So if they know that your car is a 15-minute walk from your office location, they can actually send you a notification to say, hey, it's about to rain in 15 minutes, you better leave now, or better leave soon. So once again, it's nothing new that we know roughly what time is going to start raining, but being able to kind of bring that data and stitch it together to give you a wholesome picture of how to perform your life better, how to perform your duties better, that's the advantage here. So what do these guys have in common? Try to boil it down to basically 4 points. So they're federating sources of information, like I said, multiple APIs, multiple data points, bringing them together for you. They're able to perform calculations, forecasting, and automation. So, whether it's forecasting which flight you should be on or forecasting what time your driver is going to be there, it's relatively simple calculation. And of course, as I mentioned before, distilling that information. So these automation tools are processing a lot of information, but they distill that information into tiny bits of information that just give you exactly what you need to know, no more, no less. And then last but not least, they present you an action for an immediate decision. Should I leave now, or should I stay longer? Is my package delivery about to be here, or is it about to rain? So again, makes it really simple for you, very obvious what to do. Any questions on this before I move on? Okay, so we started with painting a grim picture of healthcare, We looked at the outside world, looks beautiful, sunny. Now let's see if we could maybe bring these two together. So let's just quickly kind of think about what we've got these days. So a typical health system today has a bunch of solutions to manage their workflow. A typical imaging department probably has a hospital information system, HIS, radiology information system, RIS, or an EHR, PAC system. They probably have a couple of specialized applications for 3D reconstruction and specific measurement tools and things like that. Maybe some reporting software like voice dictation software, and so on and so forth. So the concept here is similar. You've got multiple points where you've got data that's being generated, data you can, in theory, mine and come up with clearer picture of, hey, what's going on in my department or in my hospital. Of course, operational financials, like am I actually getting compensated properly for my exams, and clinical decision support, which is a relatively new thing right now in healthcare. So is this exam I'm ordering appropriate? Is this medication that I'm prescribing the best choice here? Patient has allergies, or there's a cheaper alternative, that kind of stuff. Click. Okay. This is not my graph. I'm not smart enough to come up with these things, but I did steal it, and it is very, very interesting. Let's kind of look at sort of where things are headed. So a standard report is kind of like a dump from your database. Think of like something like a CSV file. It's just a report. That doesn't really give you any proper information. Ad hoc report would be a report that kind of distills information down a little bit, so it can give you quick summaries of, okay, this is what's happening here, or how often it happens, or how late things are. If you kind of combine the two down, you get the query drill down report. So it's a report that gives you summaries, but elements are clickable, so now you can actually dig into the more detail. So let's, for example, say the report are telling you, oh, your patients who are arriving for a CT scan are having to wait an hour on average. So it's already distilled that information for you, but then you can click on it and kind of see the list of patients, and then drill through the patients to figure out, were they late because we're running late, or are they late because they're showing up late, or so on and so forth. Then next step up would be to get alerts. So a lot of hospital systems nowadays have systems like that in place. So patients are now waiting above an hour for a CAT scan. Somebody gets an email or a page to say, hey, figure it out, get more techs, or bring more help staff to help the patient find their way around the hospital, so on and so forth. But this is where we draw the line between sort of just reports that still wait on somebody to figure out what the problem is and figure out the solution, and then the next level up where we actually start coming up with more interesting information and actionable items. So next step up where we would be going next would be statistical analysis. So just being able to kind of look at the historical data and be able to forecast just a little bit in the future. And then forecasting and exploration would kind of be built on top of statistical analysis. Predictive modeling, so artificial intelligence, machine learning, that kind of stuff. And then ideally, you get to a point where we can start to optimize by being able to suggest action items. So take the example of patients having to wait an hour. You've got some kind of AI algorithm that looks at it and decides, you know what, you just simply don't have enough techs. For the next shift, you should probably plan to have more techs. And maybe ideally speaking, it even just gives you like an OK button, and it'll automatically update the schedule, right? You've got a blank page here. You could do pretty much whatever you want. You could start simple and kind of grow it more and more as you go along. Is this clear so far? Does this make sense? Good. Probably makes sense because it's not my graph. Hello? There we go. Okay, so kind of trying to tie it up again for what healthcare has these days. Right now, if you want to try and get any information out of most of your healthcare systems, it's labor and time intensive. Like being able to get to somebody's database, pulling information out of it, I probably would rather have my teeth pulled out. It is pretty painful. And of course, we don't really have any standard format for logging, even though we do have standards, like IHE, Aetna, and other standards. But let's face it, these standards are very loosely followed, And more often than not, if I take the example of IHE Aetna, the data goes in one particular format, but then the vendor stores it, every vendor stores it in a different format. So when you pull it out, it's not consistent across different systems. It's just a mess. It just doesn't work. And last but not least, delayed. So by the time you're able to pull the data out of your system, super dirty data, you clean it up, you mash it up together from multiple systems, you try to paint a picture, may have already been late. So if we go back with the example of patients having to wait more than an hour for a CAT scan, you probably won't find out about it until a month later. And now you've got a whole month of people having to wait an entire hour, and they hate your facility because it's slow, right? So it just doesn't make for a timely decision, especially when you compare it to all the examples we looked at from outside of healthcare, where the information is always there. It just makes life so much easier. Now, for those of you who are not familiar sort of with the workflow, I just kind of came up with a slide, or actually stole this slide, I should say, to remind you of what it looks like and the amount of information that is generated along the way. Wow, people really like this graph here. I see a lot of phones coming up. Enjoy, it's all yours. The slides are online. Feel free to reuse it if you want. So it starts with a schedule. So let's say I'm a patient, I'm coming in for a CAT scan, they're scheduling me, okay, that generates some information, and then you show up to your exam, the technologist will actually get your images taken, so I'm laying down, they scan me. That image is then sent to a radiologist, which looks at the image and creates the report, but it's not done there. Now you see the cloud here, of course this is wishful thinking, but the image gets stored somewhere on some server along with the report. But then the radiologist is usually not done because sometimes the collaborating physicians, whether it's a specialist or your family doctor, may look at the report and be like, hey, I need to talk to the radiologist, not super clear on the information. So, they pick up the phone, they do that. Of course, sometimes it may take one more round of ordering more tests or more exams to see. And then, of course, outcomes and follow-up care. So, your CAT scan, for example, came out positive. We need to give you medication, or we need to do something else. Or maybe your CAT scan came out negative, but they found out something different, coincidental. So then you have to follow up on that. So again, it's a pretty rich ecosystem. But on the side of the ecosystem, you have the system admins who are trying to kind of break it down to look for opportunities for improvement, hopefully continuous improvement. So I've been drilling down on the one example of patients being delayed for a scan, but reality is there's a lot more than just that. Like that was a convenient example because it rolled around. But every step in the process here could present a challenge and room for improvement. Like I know hospitals that, for example, struggle with scheduling. They just simply cannot hire enough staff to keep a handle on scheduling. Just doesn't happen. Others who struggle with making sure they have enough technologists, or sometimes struggle with having maybe too many technologists one day and too few technologists the other day. So again, it can be a complete mix and match. There's room for improvement everywhere along the way. I've seen hospitals here that have experimented with how collaborating physicians and radiologists can communicate. So some hospitals have actually experimented with putting a phone number at the bottom of the report where the physician can call the radiologist to chat. Other hospitals are more protective of their radiologists and will only allow you to email them or call a general number, leave a voicemail, and hope they call you back. Everybody has a different way of doing it. But the common denominator is if you don't have the data, you don't know what's wrong. Did I say that enough times today? Okay, so some quick examples of things we could improve. And again, this is very imaging focused. I apologize for those of you who are not familiar with imaging. But think about something like utilization, okay? If you have a scanner, these things cost a lot of money to buy, cost a lot of money to maintain, and cost a lot of money to run. But ideally speaking, what you'd like to do is be able to run it 24/7, or even if you run it during business hours, run it nonstop so you make the most out of it, okay? But that's a very common problem. So if you ever look at a sort of a utilization graph of a CT scanner, there's a lot of idle time in between because of scheduling inefficiencies. If you look at staff performance, that can be a problem, right? Now, of course, we're human beings. Sometimes you just have a bad day or something. But nonetheless, if we could find a way to optimize this, put more staff, or maybe you don't necessarily need more technologists, but you just need ushers who help people find their way, get in, find the change room so they could put the hospital gown, that kind of stuff. Maybe that's all you need. Repeat imaging is a common problem. You've had your images taken in one state, you've moved over, and now it didn't exist, so they have you take the exam again. Low value imaging, so imaging that doesn't actually give you good return on money. Uptime, that one is pretty obvious. Image and report quality, so a common problem in imaging is a technologist will take an exam, ultrasound for example, but the image quality is actually not up to snuff, so the radiologist rejects it, and then the patient has to go back and be re-examined. Again, a problem. What if we could, for example, have a tool that can tell the technologist in real time, hey, this is decent enough, or no, it isn't. Just an idea. Follow-up tracking is a big problem. There are actually some states in the United States that are turning this into legislation, because it's very often that you end up doing a scan for problem A. In the process, they discover that you have problem B. But then making sure that you or your doctor know that information is a much bigger problem than you'd think. Very, very big problem. I actually think the other day I was reading an article about somebody in the UK who sued the NHS because they had an incidental finding that was not reported to the patient, and then the patient ended up dying of cancer. So, and that's just one example, but this happens all the time. It's a very, very serious problem. Equipment adjustment, maintenance, some of these things could be as simple as reminding you that, hey, your CAT scanner is up for maintenance. If you don't maintain it, this could stop working, and now you have downtime, and you've got a whole bunch of patients that you need to reschedule. Training, education, I won't go through these in full detail because we're actually running out of time faster than I anticipated. So before I move on to my practical examples, did anybody have any questions? Are you all quiet because I depressed you, or are you all quiet because you didn't get coffee? All right, so let's try. Again, this is the dreamy part. This is stuff that I made up relatively in a hurry, but just random thoughts of what if we could do this. So if you look at the patient resource, right? So patients hopefully have contact information, like telecom. What if we could just remind them of an upcoming appointment? Think about it. I know this kind of exists, but it's very spotty. Very few institutions have it. A lot of them don't. I know in my case, none of the institutions I deal with have this. You usually get your appointment scheduled a month or two in advance, and it's up to you, the patient, to remember that. Luckily, I'm a pretty organized person. This is not a problem for me, but I know a lot of people in my life who are not organized at all. So then exam day comes and they couldn't even remember. So then, you've got a no-show, and that's a problem because that's scanner downtime. You took somebody else's spot, wasted money, wasted time. It's just a waste all around. What if we could also take that opportunity of being in touch with the patient to prepare them for their experience? So the simplest example is remind them, hey, for this scan, you're not supposed to eat 8 hours in advance. But you could also offer more information, like, hey, for this exam, you should expect to be here for about an hour. Or, hey, for this exam, make sure you report to room 1, 2, 3, 4, so the patient can actually navigate their way around the hospital, which usually is like a maze, a bit easier, right? Maybe if you're super high tech, you actually have like a little map of your hospital that you could send to them so they could find, plan in advance their way within the hospital. Now, if you have an address for your patients, with a little bit of help of something like Google Maps, you might be able to tell if this patient may have difficulty getting to your appointment, and if so, maybe combined with a little bit of known history of no-shows for this patient, you can actually double book. Now, of course, when I say double book, most people are like, no, that's evil. it's reality. You sometimes just need to do it because, like it or not, no-shows is a big problem in imaging. So sometimes you just have to double book to make sure that you're running your practice as efficiently as possible. Language would be another one. So what if you have a patient that doesn't speak the local language? That would help you prepare by having an interpreter in advance. So again, dreamy stuff, but I don't feel like any of these things are necessarily that hard, right? Like somebody could whip this up relatively quick. And this is not a medical device. You don't need any regulatory approvals or any of that stuff. This is more like helping with workflow. If we look at imaging study, procedure code might actually help us. No, actually, this is not really entirely correct. Procedure code would be more like for a service request here or a procedure request. But nonetheless, the point is, what if I could use this to forecast staffing schedule? And I mean, you could do this both ways. You could be looking forward at your service requests for what procedures are being requested, but you could also look backwards at, historically speaking, what do we do the most? Do we do a lot of CTs or do we do less of, X-rays and so on and so forth? Maybe you're in the market to buy a device. Some historical data with some forecasting data may actually help you. I only have X amount of money. I think I need a CAT scanner and I need an MRI scanner, but I can only buy one. Which one should I buy? Do you go with your gut feeling or do you go with data? I would go with data. Hopefully it would be right. Endpoint is a forgotten resource with an imaging study that tells you where you can go to the PACS and get some DICOM information. So here's an example when we talked about federating data from multiple sources. This would be a golden one. So think about all the information you have in FHIR about the patient and the study, and then you could take DICOM information, marry the two, and now you have a much richer picture about what's happening. You have the time that the study was started, and you could also use that to correlate to something like when the report was created. So this is actually a well-known metric right now in the imaging industry. They call the report turnaround time. So now it's not exactly this. This is actually not the exact right definition. Usually it's more like when the study was finished to when the report was created rather than when the study started, but FHIR doesn't actually track that. So if you wanted the time that the study was done being captured, you'll actually have to get that from the DICOM. Sorry. Any questions about any of these before I move on to the next one? Okay. Diagnostic report. So the conclusion field is usually rich of follow-up recommendations. So again, follow-up recommendations is when you went in to do an exam for problem A, they found that you have problem B, and they needed to tell you. But in most cases, they're not right now. That goes into the report. Somebody reads it. You may or may not hear from anybody. Most likely you would not, unless it's really major concern. But if we could automate this, then we can now equally alert people whether it's a really serious problem or something that you should look at. Now, of course, I do realize this here would take a little bit of intelligence. Maybe you need a little bit of natural language processing to be able to do this, or ideally, if your institution is advanced enough that things are actually coded properly, maybe that will help you discover some of that information in a more structured way. It depends on the implementation, but the thought process is still the same. So this one we actually talked about, so correlating the turnaround time for a report, so when the study was finished versus when the report was actually created. That's a common one. In the specimen observation, think about what happens if you can correlate information from multiple departments within the hospital. So for example, if you're being screened by cancer and you get sent for an exam, sometimes the imaging exam may not be definitive. So they think there might be a tumor, but they're not 100% sure. So then you're sent for something like pathology. And then pathology will take a tissue sample, and then they confirm. The radiologist does not know if that cancer was confirmed or not. But if you had a system that allowed the radiologist to say, hey, I'd be curious to hear what pathology thinks of this when it's done, Then, a week later or a month later, when that result comes out of the pathology department, you could be notified to say, hey, Mr. Radiologist, remember this exam from a while ago? Well, it turned out that this was malignant. You're good. It's an educational opportunity, because then the next time this radiologist reads a similar image, they're more well-suited to interpret it correctly. Obviously, they go to school for enough number of years to have the education, but every one of us could use some continuous improvement. I think we all agree on that, right? Let me see, did I have more? Device resource is another example. I don't know how much it's actually used in real life, but if you think about something like expiration date, what if you could just simply trigger, an alert email to say, hey, the following devices are expiring this month. Think about replacing them, right? Like this, and especially to me with my IT background, this always reminds me of certificates, like SSL and TLS certificates. If I had $1 for every time somebody forgot to renew the certificates on time, I'd be pretty rich. Model number, part number, like what if you could correlate that information to check for firmware updates or maintenance records, or just the fact that these records need to be stored somewhere. Like and this may not sound like a big deal, but believe me, in healthcare, this is a big deal. Because if you have a problem, say a patient was misdiagnosed or something, and then it turns out your device is not maintained or you don't have the records, especially in a place like the US, talk about a big lawsuit and a lot of money to be lost here. So it's a very simple thing to do. It may not sound like much, but it can help you prevent a much bigger problem. And of course, you are regularly audited for things like making sure that you're compliant and keeping your devices up to snuff when it comes to maintenance. Okay. So this is my last slide. If any of you decides you're interested in building something here, these are some profiles that might be interesting for you. So the first one is the one I mentioned, the Aetna Profile. So that's the one for audit messages to be sent. I'm not going to mince words here. It's not the prettiest profile, but it is prolific. It's everywhere, and it's relatively well implemented.
What does IHE stand for again?
IHE is integrating the healthcare enterprise. So IHE is a standards body. So like if you think about HL7, but IHE isn't so much concerned with creating new APIs and semantics for languages, but more like try and make the best of what's already available to define a set of transactions to solve a problem. So more often than not, the stuff they build is built on FHIR or DICOM Web or even other standards to solve a healthcare problem. Okay? And IHE, for the uninitiated here, has a number of what they call domains. So these are problems that are being solved in different parts of the healthcare industry. And one of them is actually IT. So they try to solve IT problems, plus radiology problems, plus ophthalmology problems, and other domains as well. Standard operation log of events is actually a brand new one, and this one is actually close to heart here because this is more involved with analytics more than anything else. So it's very applicable here. They actually have a new one called Mobile Alert Communication Management, and I believe this one's actually built on top of FHIR. I have not looked into the full details, but I believe it's built on top of FHIR. So it just talks about how you can go about notifying people on a mobile device. Clinical decision support. You probably have heard enough about clinical decision support already, so I'm not going to go into the full details here. And if you do decide to do any of these things, I highly recommend you go to an IHE Connectathon and validate your work. So again, for the uninitiated, IHE Connectathons is a place where vendors can come in and test their stuff together. Because usually, if you think about any of these problems, it involves multiple actors. So maybe you're the one developing a solution to do mobile device communication, alerts, but you still need to have some kind of PAC system and maybe FHIR server so you can actually read the data. So when you go at the Connectathon, then you have the different vendors and everybody connects and works together to validate the work. And at the end of it, you get a certificate of all the profiles that you passed, which then you could actually use when you respond to an RFP for a potential customer to say, look, we've actually validated our stuff, it works. You don't just have to take my word for it. Okay, and the connectathons are actually very nice environment too, like very friendly. It's not like, us versus them kind of thing. People work together and try and solve problems together. All right, and this is it for me. Any questions, any concerns? Did this hit a point with anybody? Did it make sense? Am I too dreamy? No, hopefully. Yeah, please go ahead.
Actually, just a comment, not a question. This hit the right spot, especially with the follow-ups, because our radiologists are very interested in closing the loop.
Mm-hmm.
And the integration is out there, just somebody needs to do it. It doesn't even have to go to FHIR, but it's a problem that needs to be solved.
Yeah, it's a relatively simple one. Yeah. Any other questions? No? Okay. Yeah.
Maybe in the sense from your last slide, you mentioned the number of IHE profiles.
Mm-hmm.
Do you know if in the IHE world, working groups or people are working on closing the loop like this also for analytic purposes? So for the prediction part of it, not a use case that was listed here.
Yeah, it's a common saying that the standards are usually behind the real world, and it kind of makes sense. Like, for example, right now, IHE is working on a number of profiles to solve, like, how do we deal with machine intelligence and machine learning in medicine and healthcare. I don't think these profiles are out yet, but yes, I mean, generally speaking, they are behind. It's usually for a good reason, because like somebody needs to try something out, and then we try to come out with a standard way of doing it. But of course, IHE is also an open organization. So if anybody, if somebody is not interested in building but interested in contributing to standards, you could always join IHE, join one of the committees, and help develop a new standard or enhance an existing standard. Right? One example of an IHE profile probably a lot of people here know about is XDS. A lot of people hear the word XDS, but they don't hear the IHE part. So like that's an example of the work they do, and it's very iterative. So XDS has been through multiple iterations.
Yeah, but I meant, your use case is basically about continuous improvement and analytics to feed that.
Yeah.
And that's a different type of thing than the process-oriented stuff, which is more like in these profiles.
Yeah. They have two profiles on the work. I honestly don't remember what they're called, but if you want me, I can look it up for you afterwards. Yeah. Okay. Any other questions? All right, very good. Thanks for your attendance. I appreciate it. Enjoy the rest of the conference. Thanks.